Devarakonda. I'm doing a tutorial on matrix multiplication. So basically, let's talk about matrices. So what are the applications of matrices? So graphic software, matrices are used in graphic software. It is used to process linear transformation to render images. A square matrix is one with exactly as many rows as columns, can represent a linear transformation of a geometric object. For example, we use matrices in Cartesian xy plane. The matrix reflects an object in vertical y-axis. And it's also used in programming, which is for the encryption of message codes. So now let's deal with the types of matrices. So there are basically a lot of matrices, but we deal mainly with 6 matrices, that is rectangular, square, diagonal, scalar, identity, and zero matrix. So basically, a rectangular matrix has is a matrix where number of rows is not equal to number of columns, and a square matrix is basically a matrix where number of rows is equal to number of columns. A diagonal matrix is a matrix where in, let's say, A1, A2, A3, B1, B2, B3, C1, C2, C3 are the elements of a matrix. And a diagonal matrix is a matrix where one element of a principal diagonal is non-zero and the rest are zero. So this 1, 0, 0, 2, 0, 3, 0, 0, 0. So this is what basically is a diagonal matrix. Now next comes scalar matrix, where all the diagonal elements are the same. That is 1, 2, 3, 3, 1, 2, 2, 3, 1. Where all the diagonal elements of a matrix are the same. Next comes the identity matrix, where all diagonal elements are 1. That is 1, 0, 0, 0, 1, 0, 0, 0, 1. That is, all the diagonal elements in the matrix are 1. And next comes the zero matrix, where all the elements are 0. That is 0, 0, 0, 0. So now we are going to deal with matrix multiplication. So before we go into matrix multiplication, there is a small term which we all should know. That is transpose of a matrix. So transpose of a matrix is a new matrix where rows are columns of the original. That means if M is a matrix, then transpose of a matrix is described as M or T. Okay, now let's go into matrix multiplication. So before going into matrix multiplication, let us know the basics of multiplication that involves matrices. So for example, if we take A is equal to A1, A2, so on, A to N, that is a 1 into N row matrix. And if we take B equal to B1, B2, so on, Bn, which is a n into 1 column matrix, then the product is defined as, product of AB is defined as A1, A2, so on, An, B1, B2, B3, Bn, so on, equal to A1, B1 plus A2, B2, so on, An, Bn. And this rule is generally called as inner product. So this is what are the basics of an matrix multiplication. So now let us go into multiplication of 2 into 3 matrix, and 3 into 3 matrix. Here 2 into 3 matrix involves 2 rows and 3 columns, and 3 into 3 involves 3 rows and 3 columns. So the basic principle in matrix multiplication is, let us take A is equal to 4, 3, 2, 5, 6, 3 and 3, 5, 2, and B equal to, let's say 3 minus 4, 3, 1 minus 2, 2, minus 7, 11 and minus 9. So now let's imagine this as A1, A2 and A3, B1, B2 and B3, and C1, C2 and C3. And now let's take this as, let's say capital A1, capital A2, capital A3, capital B1, capital B2, capital B3, and C1, C2 and C3. Now the basic rule in matrix multiplication is, we take the first row and we multiply with the first column of the second matrix, and this goes on pretty much to every row and every column consecutively. So that means A1 A1 plus A2 B1 plus A3 C1, and this goes for the second thing, A1 A2 plus A2 B2 plus A3 C2, and the same A1 A3 plus A2 B3 plus A3 C3, and next, and then we go for the second row and the first column. So B1 A1 plus B2 B1 plus B3 C1, B1 A2 plus B2 B2 plus B3 C2, B1 A3 plus B2 B3 plus B3 C3. Next we go for the third and the first one, C1 A1 plus C2 B1 plus C3 C1, and C1 A2 plus C2 B2 plus C3 C2, C1 A3 plus C2 B3 plus C3 C3. So this is what is a 3 into 3 matrix multiplication. So now if we take from the previous example, A is 4, 3, 2 and 5, 6, 3, this is 3, 5, 2, and B is 3 minus 4, 3, 1 minus 2, 2, minus 7, 11 and minus 9. So the product of AB, that is 4 into 3 plus 3 into 1 plus 7 minus 7 into 2. So we basically multiply the first row with the second with the first column of the matrix, second matrix, and so on. If we carry on this procedure, we get a result, and that result is in this case an identity matrix. So that is, and this is an identity matrix as we know. And now let's take BA, that is 3 minus 4, 3, 1 minus 2, 2, minus 7, 11, minus 9, into 4, 3, 2, 5, 6, 3, 3, 5, 2. So this, now let us take the first row and the first column of the second matrix, and then we multiply minus 4 into 6, minus 4 into 5, sorry, plus 3 into 3. So we continue the same process as mentioned above. Then we get the same identity matrix. So as we can see here, we have learned a new case, that is AB is equal to BA, that is matrix of B is inverse of matrix of A. So this is basically generally written as A inverse, and this term is called as inverse. So in equation of inverse is basically A inverse equal to A inverse A equal to I. So this is the basic principles behind matrix multiplication. I hope you understood the tutorial. Thank you.